Okay, so we're going to handle 2.1 day 4, the last section of 2.1. And that is going to be dealing with solving a linear inequality. So our first example here, we want to solve the inequality, graph the solution, and write the solution set in interval notation. All right, so we have 3x minus 7 greater than, that's our inequality, and 2 times x minus 4 in parentheses minus 1. So for this one, let's go ahead and do the distributive property since we have things inside of parentheses here. So we'll start out with saying we have 3x minus 7 still, nothing to do with that. I'll draw the greater than sign a little bit better. Okay. And then we're going to take 2 times x and then 2 times negative 4. So 2 times x gives me 2x. And then 2 times negative 4 gives me negative 8. And there's 7 minus 1 out there. So now we can actually combine like terms, start out with that. So we can take 3x minus 7 is greater than 2x, and then we can say negative 8 minus 1 is negative 9. And now let's go ahead and simplify this even further. So with this, let's go ahead and take 2x from both sides. So we will minus 2x minus 2x. So these will go away, and we'll be left with a negative 9 on the right side, and we have 3x minus 2x, which gives us x, and then we have minus 7. Now let's go ahead and add 7 to both sides. If we do that, if we add 7 to both sides, on the left hand, negative 7 plus 7 goes away, and we're left with x. X is greater than, and then negative 9 plus 7. Now 9's a bigger number. 9's our bigger number, so the negative is going to stay, and then we're going to say if we're short $9 and we get $7, how much do we have left still? Or how much do we still need? $2, right? So if you're short $9, you get 7, you're still short $2. So x is greater than negative 2. And that is going to be an inequality answer with that. Now we need to set it up in interval notation. Well, hopefully you guys remember, since there is no equal sign here, the parentheses is what you'll be using instead of square brackets. So because it's not equal to, it's not actually going to touch those values. So we're going to play it out. So we're saying x is greater than negative 2. So our lowest point then is negative 2, and it's going to go up to positive infinity. So that's your interval notation. Okay, and then we need to graph this guy. So if we're to graph it, we'll draw our little lines here. We'll see we're starting at negative 2, looks like. So negative 2, go 1, 0, 1, 2, 3, 4. We'll go up like that so far. And with this, to actually draw this because we are not actually going to touch -2. We have an open circle on -2. I'll make this a little thicker here, make this work a little bit easier. And then we're going to draw a line going this way because it's all everything, oh goodness, greater than -2. So there's your graph. So it asks for these two things. It asks for interval notation and the graph. Okay, let's go on our next example. So solve the inequalities, graph the solution, and write the solution set in interval notation. Okay, so first off, let's do A. Okay, so let's go ahead and add 5 to both sides. Okay, in this case the 5's go away, and left with -2x less than 7. Well, then we're going to divide by -2 on both sides because the opposite of multiplication is division. The only trick is when we divide by a negative, the sign is going to change. So now that sign is going to be greater than. And we're now going to have on this side, we'll have x and -7 halves. So x is greater than -7 halves. So for interval notation, it's not equal to, so it's just brackets. -7 halves is the lowest we have there going on, right? And then we're going up to positive infinity. To graph this guy, we're just going to label this as best we can. So we'll start out with saying -4, -3, 2, 1, 0, and going forward like this, 1, 2, 3. Okay? And we're going to say that we've got -7 halves, so it's a little over 3, or a little over -3, so somewhere in there, and it's greater than, so it's going this way. Okay, so on this one part B then, we can do a few things to get this one set up for us. We're going to distribute this -6 in. So -6 times x is -6x. And -6 times -3 is plus 18. Negative times negative gives you positive. And then you're going to go with greater than or equal to 2, and then we distribute this -2. So -2 times x gives me -2x, and then -2 times -8 gives me plus 16. Okay, so I can't combine anything over here, so 6x plus 18 is still greater than or equal to, we can combine something over here. We have 2 minus 2x plus 16, so 2 plus 16 is 18, so we say -2x plus 18. All right, so let's go ahead and let's make this a little bit easier to do. Let's go ahead and subtract 18 from both sides. Okay. If we do that, then these 18s go away. We'll have a -6x greater than or equal to -2x. And these 18, positive 18 minus 18 goes away as well. Okay, so now let's see what we can do here. Now we need to go ahead and let's add 2x to both sides. Add 2x. If we do that, the two x's on the right go away, and we're left with a 0. And on the left-hand side, we got a negative 6x plus 2x, so the bigger number is negative, so we're going to leave a negative sign, and we're saying 6 minus 2, which gives us 4x. Now, to get rid of that negative 4, opposite multiplication is division. So we're going to divide by negative 4. What happens when we divide by negative? The sign is going to change. It's going to go the opposite direction. So now, negative 4 and the x go away, so we're left with x is less than or equal to 0. So for the actual set notation here, or interval notation, I'm sorry, that we're going to look at. So x is less than or equal to 0. So we have negative infinity as our low value, right? This is going on forever. And 0 is our upper bound. Well, it's less than or equal to 0, so equal to means it's a square bracket, and you'll never touch an infinity or negative infinity, so there's always going to be just parentheses there for that. As far as a graph, we'll just say 0 is right there, and we'll go negative 1, 2, 3, 4, so negative 4. And we're just going to draw a solid dot at 0, not an open circle, solid dot because it actually touches. And this line's going all the way to negative infinity. Alright, so the last little example here we got to work on is going to be dealing with a pretty big problem. Okay? So let's see what we got. So we got negative 5x plus 2 divided by negative 3 is greater than x plus 2. So again, we're graphing and writing the set in interval notation as well. So we got negative 5x plus 2 divided by negative 3 is greater than x plus 2. Well, first off, let's go ahead and multiply by a positive 3, by this negative 3 on both sides to get that negative 3 off, right? So if we multiply this whole side by negative 3 and this whole side by negative 3, what is that going to do to that sign? If you multiply or divide by a negative value, it changes the inequality. It changes the sign. So that guy is now going to turn this way. And so the negative 3's on the left go away. We're left with negative 5x plus 2. And then I'm going to go ahead and distribute this in here to save a little bit of a step here. I'm going to say negative 3 times x, so negative 3x, and then negative 3 times 2 gives me a negative 6. All right. Now let's go ahead and let's see. All right, I'm going to go ahead and take, I don't want to do this. I'm going to add 3x to both sides. So I've added 3x to both sides. So negative 5x plus 3x gives me negative 2x plus 2, which is going to be less than, and the negative 3x plus 3x goes away, so negative 6. Alright, so now I'm going to subtract 2 from both sides. And if I do that on the left, I will have negative 2x plus 2 minus 2 goes away. So we have less than. And then we've got negative 6 minus 2. So if we're $6 in the hole and we lose another $2, well, now we're $8 in the hole. All right? All right, so now we got to do another little crazy thing here. So now we got negative 2x is less than negative 8. How do we get rid of that negative 2? Need to divide by negative 2. But what happens with that sign when we divide by a negative value? It's going to change. So now that value is greater than again. Okay? So negative 2's go away. I'm left with an x. And then negative 8 divided by negative 2. Negative divided by negative is positive, so we should get 4. All right, now I think I want us to do it. As far as interval notation, so x is greater than 4. So our lowest number is 4. We're going to positive infinity. And since it's not equal to, it's just parentheses. And for our graph, we're simply going to go with, I'll say here is 0. Let's say 1, 2, 3, 4, 5, 6, 7, 8. We'll say 8, just to give some lines there. And with this, we will have an open circle on 4, going to positive infinity. All right, guys. Well, that takes care of the lesson for 2.1, day 4. It covers all of 2.1 now. We've definitely taken care of all that. And hopefully you understand solving for inequalities now a little bit better. And I'll see you tomorrow.